Yes, welcome again to our wonderful lessons. As you can hear the song at the background, this is a song by Bob Marley titled Three Little Birds. To all my students out there, my EDEXCEL students, A-level EDEXCEL students, I say listen this evening, it's all gonna be alright. You can do what people think you can't do. Today we're going to be solving questions on calculus. Of course, some of you are writing your papers next week, and maybe some of you after the fortnight. But then, what are you going to write when you get there? I can assure you, I am going to demystify the solutions to these problems. Let us begin. Question 1. This is my message to you. Are you ready? It says, the curve C has equation y equals 3x raised to the power 4 minus 8x cubed minus 3. Find the y dx. Of course, you know this is the y dx, and the y dx simply means the derivative of y with respect to x. Now, let's not forget that when you have ax raised to the power n to be your y, your dy dx is equal to n times a raised to the power n minus 1. So this is the formula you're going to use. So this is a polynomial. So this is pretty simple. It means the y dx for the first one will be 3 times 4, that is what? 12x. You subtract 1 from the 4, that is 3, minus 3 times 8, that is what? 24. X raised to power 3 minus 1 is 2, and minus 0. When you differentiate a constant, you will always get 0. Do not forget that. That's one interesting thing about calculus. Now, so many of us don't even know why we're going to get 0. We don't understand why we get 0. I'll tell you this. Don't forget that 3 is the same as 3x raised to power 0. So when you say 3 times 0, that's going to give you 0. And then it writes up that. Now, eventually, your answer is just going to be 12x raised to power 3 minus 24x raised to power 2. This is your answer. The second one says, let us solve for d2y dx squared. d2y dx squared is simply the second derivative, that is, differentiate the first differential. So in that case, since your dy dx is 12x raised to power 3 minus 24x, then it means that your d2y dx squared will be, you have to differentiate this function, which is 12 times 3, that is what? 36, x raised to power 2 minus 24. Okay, now, this is the solution to the second question. So let's quickly go to the next one. Question B says, verify that C has a stationary point when x is equal to 2. Now, what do you understand by the word stationary point? You know, when you consider a graph, for instance, and then you have something like a curve like this, so we have what we call turning points. Now, take note that at stationary point, your dy dx is equal to 0. So, what's our dy dx? Our dy dx, initially we got 12x raised to power 3 minus 24x. So that will be 12x raised to power 3 minus 24x is equal to 0. Okay, now do not make the mistake by moving minus 24x to the other side. So what you do first is factorize. You say x is common, but look at it very well. It's not just x that is common. 12 is also a common factor. So you say 12x is a common factor. When you bring that out, you have x squared minus 24 divided by 12, that is what? 2. Okay, now let's go back again. I think you have 4 times 3, 12, 12x raised to the power 3 minus, I'm trying to recap this to be sure that we are not making any mistakes. So you have 24x squared. Okay, and sorry, I've seen the point. This is 24x squared. So this is going to be, since this is 24x squared, you have 12x squared to be the common factor, so that if you say 12x squared is a common factor, this 2 will no longer exist there, rather it's going to be 1. So you have this to be equal to 0. Now at this point in time, you say x minus 2 is equal to 0. Of course, you also know that 12x squared is equal to 0, and then you can say x is 0. Now one point, which is called a stationary point, is when you solve this, you move this to this side, and then you say x is equal to 2. Yes, it is true that C has a stationary point at x is equal to 2. So let's quickly go to the next point, which says determine the nature of this stationary point, giving a reason for your answer. Now, if you want to find out the nature of a stationary point, you can use the to be sure, let's look at the marks for this, so you do not need to take too much time in solving these questions. I say again that all you need to do right now is to find the second derivative, which you have done already. The second derivative in our above question says that the 2y dx squared is 36x squared minus 24. So 36x squared minus 24, you have 36x squared minus 24, 36x squared minus 24. 36x squared minus 24x. Okay, just 24. Alright. Now, that's your d2y dx squared. The stationary point we got what? That x is equal to 2. Substitute 2 in this d2y dx squared and see what will happen. But note that if the 2y dx squared is greater than 0, it is a minimum point. If the 2y dx squared is less than 0, it is a maximum point. So from this part, if you substitute 2 into this, 2 squared is what? 4. Obviously, you will see that the 2y dx squared is greater than 0. From this, by the time you substitute 2, you will get a number that will be greater than 0. So which means it's going to be a minimum point. Now, it says determine the nature of this stationary point. The stationary point x is equal to 2 is a minimum point. But if you want to state this, you can also find the stationary point values, or you say you find the maximum. Since you say it is a minimum, so you find a minimum value by substituting the 2 in your original equation. So in your original equation, it says y equals 3x raised to the power 4 minus 8x raised to the power 3 minus 3. Okay, so by the time you substitute that, you will get in coordinate form. So you have coordinate 2, comma, whatever answer you get there, let me say A. You can do that calculation and then you tell us what it is. But this question only says determine the nature of this stationary point. It is enough for you to say if your d2y dx squared is greater than 0, like we can see, to tell the examiner that it is indeed a minimum point. Let's quickly up to the next question. Do not forget, the full video will be posted on YouTube. You can go share and like our pages. Do not forget to subscribe as well. All the questions for EDEXCEL papers will be solved so that you can go and write your exams successfully. For now,